All right, so if there's no other questions from homework, we're going to talk about chapter 2 stuff. Chapter 2 starts off really nice. So let me see. Oh. What do you guys think about this? So, chapter 1 was exciting, definitions. Chapter 2 is going to be, what do we do once we take a sample and we get data? What's the quickest way I can kind of like showcase my data, right? Not even analyze it yet, not the beginning of chapter 2. In the middle and the end of chapter 2, we start to analyze it. What do you think that means? If I have a list of data, what would analyzing the data mean? What would I do to it to start to analyze it? So if I have data of ages of gross month students, what would I do to start to analyze it? Okay. Organize it, sure. How about take an average? Right? That's a very fundamental thing I can do with any data set, right? So that's what I think when I think analyze data, as I start to calculate stuff like averages, what's the percentage of students who are older than 30 or something, whatever the hell, right? Okay, so before we do that, we just want to be able to display the data. So we want to talk about a few basic ways of displaying data. Right? Well, the first one's really, really basic, which is nice. And the name kind of gives it away a little bit. Let's see what you guys think about it. The book, I think, calls it a stem plot. I think they do say stem and leaf. It's a stem and leaf plot. You're gonna love that. It's the last phrase you expect. But it's called a stem and leaf plot. Okay, so let's take a look. And everything we talk about today is not necessarily going to work for every set of data. You'll see in a minute why some sets of data just won't really work with these. So for example, I could have people's, what do you got, Jeff? Oh God, creativity gone. Ages of people at a bus stop. Why not, Jeff? Sure. All right. Ages of people at a bus stop. So we have Lord Jeff. Sure. Okay, sure. And then 21, 25. Sure. And then 27. Okay, so write those down. So just display my data. One of these ancient techniques that are very quick, and it kind of relates to something we're going to do later that's a little more complicated. Stem and leaf. So this is a little bit weird. Do I have repeated parts of numbers? I don't know how else to say that. Do the numbers kind of fall naturally into groups? We're thinking about ages. So people in their teens, right? People in the 20s. Are you with me?
Yeah.
So stem and leaf. Doesn't matter if you could do that or not. It's the stem is the first part of it, the first digit normally, and the leaves are the other digits coming off of that. So there's definitely ones followed by stuff. Twos followed by stuff, right? Are there any threes? We still put it. It's just going to be empty. Poor little dude. And then we got fours and fives, right? And as you do this, you could put it in order also. So, for example, what about my teens?
7.
Yeah, I got a 17, so 7,
8.
8, 9. And my 20s?
1, 5, 7.
No 30s, right? So that's empty. 40s,
2, 7.
50s.
1. Yeah.
So, yes, go ahead.
Do the numbers have to be in order? So like, if you did 1 and you did like 8, 7, 9, does that matter?
It doesn't matter, but you might as well put them in order while you do that, because normally this is part A, and if they're in order, part B, C, D are easier to do.
Okay.
Yeah.
Do you not want us to put commas
No,
on the, is there a specific reason for that?
because it's convention not to.
Okay.
Yeah. So if you want to, you got to make a time machine, go back in time. Tell those crazy ass people to do this. Put some commas in. If I just gave that to somebody, can we trust that they could read it? We have to give them a little more information, right? If I just give you a map, you're like, I'm that dot, and that's the dot I want to go to. Do you have any idea how long it's going to take you to walk that? You're missing a what? Scale. So in this case, you're missing a key. You're missing the key of how to read this, right? Not a Nicolas Cage key that you find in the back of the Declaration of Independence or something. That is an adventure in my mind. A key would be like this. 1 line 7, of course, means 17. That's amazing. Only write 1. I've had students in the past write 1 7 equals 17, 1 8 equals 18. 1 9, I'm like, that kind of defeats the purpose. You just need 1, and then I can read the rest of it. Right? I like it. Now, if you turn your head this way, doesn't this sort of look like bars in a bar graph? If I say bar graph, are you guys cool with that? Now, of course, I'm looking at it and I'm realizing these kind of drifted down. It's supposed to be empty, but too bad. What sucks for teachers, when you write up on the board, everything kind of goes that way. All right, maybe you guys get that? So it's a very quick visual. It's kind of a quick way to sort it, all that kind of stuff. Thank God that the stupid, expensive calculator can sort data for us, right? It better. Okay. What? Now, here's what, all right, I was about to say, it says, here's something slightly interesting. What if my data had been this? Maybe it's not ages anymore, but I really hope there's not a 1.9-year-old at the bus stop. But what if my data had been this?
Would it be the same and you just change the key?
Yeah, this won't change at all. I would just have to do that. Pop! Do you guys get that? That's the flexibility of this thing. I like it. I like it a lot. Okay. Pretty simple, right? It kicks so much ass. You leave this off, you lose points. Because without this, it really doesn't mean anything. And of course, what if it was 170 and 420 and 510 and 470 and all that kind of shit? What would happen down here, of course? This would not change. Can you guys understand that?
Yeah, so what happens if it's like 172?
Oh, okay. That would be a different thing. Obviously, I'm going from one idea here. So if it was this, I could leave this exactly the same. And I would just change this. Bam! Right. I think you guys get it. It's basically the same idea, just move the decimal place. What you're saying is, what if these weren't all zeros?
Yeah.
Which in that case, I would put 1 and then I would have 72.
Oh, gotcha.
Yeah, so they'd be little packets of 2.
Okay.
You don't have to include the 0 in the leaf part?
Here, no.
Okay.
Why? Because. Could you if you wanted to? Yeah. And then your thing over here would be 170 equals 170, but do you see how you don't need to?
Okay.
I really want you just to see the flexibility. This is not difficult, it's not anything. I just want you to notice how much flexibility there is. As long as you can explain how to read something, you can do a lot of stuff here and make it simple. Okay, enough of that. Stem and leaf, easy shit. Let it be easy. All right, this other shit coming is not. Okay. Now, somebody was asking me a minute ago about something called a histogram. And I think did I say that word last time? Does anybody remember that? Bar graph versus histogram. So a bar graph. Bar graph. Yeah, I remember this. Would be for non-numerical data. Ford, Chevy, blah, blah, blah. Where are my Ford and Chevy people? This hilarious rivalry. It's a car, get over it. Now, so that's a bar graph. What kind of data is this? This is qualitative. So gaps don't mean shit. Right? But if I have numerical data with an actual scale, and I have a gap, that means empty class. That means nobody was between 15 and 20. Yes? Okay. So we call this a histogram. It is essentially a bar graph, but we give it a different name because it's got a little different requirements. So bar graph, this is a histogram. What do you think the class width is up here? Get in there. There you go. Dot, dot, dot.
5.
Yeah. You don't even know what the class is necessarily, but the class width is how wide something is, and these are the ones that have the same width. So the class width is 5. How many classes do I have represented up there? Let me take the dot, dot, dot away. How many classes are up there?
I want to say 4. No.
What were they? So one class is from 10 to 15?
Oh, 2. No. I don't know.
Isn't there a class from 15 to 20?
Well, yeah, but.
It just doesn't have anybody in it, but it's a class.
But what about 0 to 10 then? We just don't include
Oh,
that?
no, because it's not been demarked. I guess.
Oh, okay.
So yeah, we kind of have, has anybody ever seen the little heartbeat symbol? Oh, sorry. I mean, not on a thing, but I didn't want to take you back. On a graph in math class. Okay. I've been there too, man. I understand. This just means I'm kind of like breaking the scale just to get to the data. Because if I had the first number was 1,000, I don't want to put 5, 10, 15, 20, 25, 30. Oh, I'll get to 1,000 next class, right? So we kind of break where to go. Break the scale to get to where the data starts. Okay. So there's 1, 2, 3 classes. One of them's empty. Kick ass, all right? Because we're about to create something like this ourselves, given a bunch of data. That's where we're headed. Okay. Let me make some fresh data. This data is stale now. Get out of here. So, just to cut to the chase. Well, let's see. How many people don't have a calculator right now? Okay, not that bad. I do have 4 that have batteries. I just need to exchange this with a valid ID. And you could borrow it for the class. Nobody trusts me, that's fine. I'm not asking for your credit card. And I'll step out for a while. Sure. Okay. Oh, come on. All right, so I'm going to put some data up on the board. I'm going to show you how to make the calculator sort data. That's the most basic thing you should be able to do. So I'm just going to make some data. This is so exciting. Make a number, Jeff. There you go, buddy. How many data points is that? No idea. 6, 7, 8, 9, 10, 11, 12, 13. Yeah, this is not. Let me make a few more. Ha! All right. So this isn't that bad. If you had to do this by hand to sort it, you certainly could. It wouldn't kill you. But we are going to get larger sets of data eventually. So let me show you very quickly how to sort this in your calculator. Okay. I say quickly, but you know, things have to happen. There we go. Hey, look at that. So I got a nifty TI Calculator Emulator. Look how tiny it is. It's so cute. Oh, I see what I can do. Jeff, it's all right. All right. So if you hit, well, I should make this bigger. How do I make it bigger? I don't know. It used to be easier. Do I just do that? Yeah, okay. All right, so. I don't know if you guys can see that if you don't have a calculator, but if you have a calculator, if you can see that, what's the most important button besides on? Just to cut off my fellow smartasses out there. What's the most important button for our class? Everybody see it?
Stat.
Stat! Crazy. There's also a math button in there. Yes? Do you guys see the math button? I wish I could just push up here and it would do it. That would be so awesome. Math button, very intriguing. You're not sure what's going to happen if you push that. And of course, the stat button. So hit stat. Stat. And this is very boring looking. But you can see something interesting. There's sort. Why are there two sorts? Yeah, ascending, descending. I like it from small to big, big to small. Don't worry about the other stuff. So if you hit edit, you can put stuff into the list. If you go to calc, it will calculate something about the data you put in. And of course, tests are going to be later this semester, where we start to test differences between groups of data and stuff. So let's go to edit, enter. Tell me if yours does not look like that when you hit. What is happening with yours? Are you missing a list?
No, I think I just have the wrong calculator.
Totally. I think you're in the same boat. Same boat. So I have two left. And you need to get a TI 83, 84, right? So if you want to borrow one, you can. If you have an ID. Everybody else good? Oh, what's up? Oh yeah, you got shit in your list, right?
Yeah.
Okay.
You check mine. Most of it, I think I might have the wrong one as well.
What?
I think I might have the wrong one.
You totally did. Yes. All right. Thank you.
Like clear?
Yeah, you go up to the list and hit clear. Don't hit delete. What's up?
I've done this Cassie since my sophomore year of high school, and I know how to use it.
You're good. If you know how to use it, good, because I don't. Okay. I mean, I know some stuff, but I don't know the rest. All right. So everybody else is good, right? You got L1. Cool. All right. So let's put the data in. Let's see where to go. There it is. So the most exciting part of statistics is data entry. So everybody please remain calm as you do this. All right, so did you get everybody? All right, yes.
How do I delete the information that's already in?
Oh, all right. So here, let me put some shit. So shit. Oh shit. I put too weird of a shit word. Shit stuff, business, crap. Okay. You would go up to L2, for example, and just hit clear. Enter. Clear. Why are you not working? You don't like my mouse at all. That sucks. Am I stuck in something weird? There we go, sorry. Back up. Try this again. There, up, clear. Okay, why are you freaking out? So this is what happens when they update here, enter. My mouse is just not. My computer doesn't like my mouse. That's never good. Did that eventually help?
Yes. thank
Okay,
you.
sorry. Just don't hit delete because then your list goes away. All right, and what happens if you do that? So if you go up, everybody go up to L2, make the cursor on L2, and then hit delete. Ha ha ha! I'm sorry. Look what I made you do. No. So now hit stat. Oh my God, this is going to drive me insane. Go down to setup editor, enter. And now when you go back in, is everybody with me? When you go back in, everything's back to normal. Even if you had data in the list that you deleted, the data comes back. Aw. Okay. So now, how do I sort this thing? So we know how to do that. So go back. Which sort do you think we're going to probably want to use? Yeah, ascending. Data ascending. But now, do you see how it's got a parenthesis like a function in algebra? So you just got to tell it which list. Where are the lists? We'll look above the number 1. You see where it says L1 above the number 1? So you can just hit second. Second's like a shift key. Second, 1. So you say L1. F. Oh shit, I sorted it twice. Great. And it's very anticlimactic. It's just done. So you have to go back in. Somebody, let me know the minute you fall behind what I'm doing, okay? On technology day, it's always exciting with how many errors can happen. So if I go stat, edit, and now it's in, yay, it's magical. Okay. Sweet. You guys okay out there? Anybody ever done any computer programming?
I took a class on it.
Okay. So if you do, you have to learn sort algorithms. So there's all different ways to sort things, and some are faster than others and stuff. Anyways, nothing to do with it. So now what I want to do, now that we got that bad boy in order, we could make a stem lead. We're not going to do that because that's too easy. We're going to try to create a histogram. So here's the idea with histograms. Why do I not want to make just a bar graph where I have like 18, 19, 20? I said last time when a bar graph works really well, especially for numbers, it only works really well with numbers if you have a lot of repeated numbers. Like I have 20 18s, 21 19s. Does that make sense to you guys? Do I have that? Do I have some repeats? Yeah. Do I have a lot of repeats? No. So I'm not going to make a bar graph with like that many bars. That's crazy. Okay. So what I'm going to do instead is I'm going to do like this. I'm going to construct classes. And how tall the class is how many data points fell into that class. You guys semi with me at all? Not, do you know how to do that? Just, do you understand what we're trying to try to do? All right, so, can somebody tell me, let me see, how long is it? What does our data go from to? What's the low and the high?
The lowest 11.
The high is 50-something, right? 59? Okay. So, how far does this have to go? How far would our picture have to go?
From 11 to 59.
And how far is that? 48. I like it. So this is called the range. The range is high minus low. In this case, it's 48. Okay. Okay, here comes a major note to take. You can use from 5 to 10 classes. Less than 5 is bad. And you actually want to use more classes the more data you have. The more data you have, the more bars you need for them to fall into. Like it? Maybe? You guys doing okay? I ask that a lot. I'm worried about this. So, here's the idea. I want to go from 11 to 59. Let's say we're going to use 5 classes. Right? We're going to use, let's say 5 classes, because it's a very small sample. Would you agree with me? That is not a big sample. Okay. How do I figure out if I'm going to use 5 classes, which means 5 rectangles, right? 5 rectangles, each class is a rectangle. If I want to use 5 of those things, how wide does each one have to be so that I cover that whole thing? So that every data point has a home. How'd you get 10?
It just makes sense, doesn't it?
Well, did you do 5 times 10 is 50, which covers 48?
Yes.
Okay, good. So tell me that. I agree with you. So, but let's formalize this so that when the numbers get weirder, we know exactly what to do. So does this make sense? You guys stay with me. If I want to use 5 rectangles and I make them too skinny, that's going to be more than 5, right? Holy shit. If I make them too fat, that's going to be less than 5. So I need to figure out exactly kind of how wide to make them. So I've got to cover 48 using 5 steps, basically, right? Doesn't that sort of define an operation, a math operation? I want to break 48 up into 5 pieces, yes? And of course, what operation is that? How do I break 48 up into 5 pieces?
Division.
Division. So what's 48 divided by 5? Real quick. Do you guys know how to divide by 5 quickly without a calculator? How?
Got a 9 divided.
So you double the top, move the decimal back once. Why does that work? If I double top and bottom, isn't this 96 divided by 10? Divided by 10, just move the decimal back once. 9.6, done. Right? Okay, maybe. Some of you guys are like, I did it faster. Look at it. Okay, I like it, maybe. 9.6, do you want to use 9.6? I don't want to use 9.6, so let's always round up. So round that up to 10. So let's use a class, but now we caught up finally. You're going to use a class width of 10. Just like this one was 5, right? Ours is going to be 10. Yes?
Can you just explain again why you used 5? 48 divided by 5?
Oh, okay. I can only use from 5 to 10 classes. The bigger the sample, the more classes I'll use. This is a very small sample.
Okay.
So I'm going to use the lowest option. Could you have used 6? Yeah, it would have went in evenly, wouldn't it?
Yeah.
But that actually sucks, and I'll show you why in a minute. It doesn't suck like a lot. It's a little something. Okay. So officially, the class width is the range, right? The range, 48, the range, divided by the number of classes. That's how you figure out how wide each rectangle is going to be. Now, since we rounded up, won't it end up going past the end? Of course, we don't care. We just want everybody to have a place to go. If I rounded down, it wouldn't go far enough. That would suck. So people out in the rain. Okay, this is sending you out in the heat. Okay. Now. Yeah. So now that we know how wide each class is. We know our first data point. Let's construct our classes now. So this is going to feel a lot like those frequency tables we did from section 1.3. You guys remember that? Frequency, relative frequency. This is going to be the same thing. No, not at all? Okay. I appreciate the honesty. I'm a clue what you're talking about, Jeff. All right. So we did something last time about frequency. We just counted how many times the data happened. Relative frequency was that divided by the total to make a percentage. We're going to do the same thing. We're just going to do it in terms of classes now instead of individual data points. So the first class is going to start at 11. Is that cool? To be really honest, you could start at 10 or something if you wanted to. That's some flexibility you have. Well, you might as well start at the first data point. If the classes are 10 wide, where should the next class start?
21.
21, definitely. Why can't I put a 21 here also? Because then where would you put the 21-year-olds? Here or there? I don't care if there is any, just in general, right? So this one has to be 20 then. Are you guys with me?
Yeah.
So will you ever see the width this way if you do it this way? No. Do you see the width this way? You guys all right? I will show you a different way to do it. This is the textbook method. I'll show you a different method, and you can pick which one you like. Let's stick with this for now. Okay. So then you just keep going. The width is 10, so I just keep adding 10 to both sides. Shaboo! Here's my 5 classes. Everybody fits in there. Fish to auction. And now you just do like we did last time. How frequently did a data point end up between 11 and 20? 3, right? It's 3 equal? The 11, the 18, the 18. So there's 3 in here. Keep going.
Oh, 4 for 20.
Sorry. It's just the theme, I think, right now. 4. What else we got? What about the next class? What was the next class? 31 to 40.
4.
1, 2, 3, 4. Did you have to make some boring shit? You probably did. 41 to 50.
3.
So much variation, Jeff.
2.
And then 51 to 60. 2. Yay. What should that add up to be? What should these add up to be?
16.
They better add to be 16 because it's 16 data points, and thank God they do add up to be 16, right? You guys get that? So make that check real quick. When you're done, make sure you get all the data. Okay. Does anyone remember how to do this? The real freak. Relative frequency.
It's the frequency divided by how many data points there are.
Total. I like it. So it's just a percentage, right? There's 3 in here out of 16 total. That's all this is. It's just a part out of the whole. So 3 out of 16, somebody help me out. Is that 1825? Wait,
0.1875.
what is it?
0.1875.
1875?
Yeah.
So we'll make that 18.8% roughly. 4 out of 16 is nice, right? 1/4. Okay, Jeff, 25%. Same thing here, 25%. Chip. I'm sure you guys can see. And then 3 out of 16 we already did. Chip. 18.8. And then 2 out of 16 is 1/8, which is, what do you remember? Is it 125?
Yeah.
Now I rounded a little bit, so when I add those up, it's probably going to be a little over 100%, which is fine. Okay, is this coming back to anybody? We didn't do the classes last time, but we definitely did the freak and the real freak. Technically, no, but humans like percentages. So I've noticed in my time amongst them. So we do kind of tend to make them percentages instead of just decimals. Yeah. Okay, so I'm going to take this out to its conclusion, and then I'm going to see if I can get anybody on board with the other way to do the classes, because I told you there's another way. It's the way that I do them. So I don't care which way you do it. Right? Pick the way that makes the most sense. So tell me this. Let's do this. If I want to make a relative frequency histogram, meaning I want to use the percentages over there, what should this scale be to get them all to fit? What scale should I use here? What should each tick mark be looking at my percentages? What do you think? You guys understand what I'm asking?
Yeah.
Should I go by ones? 1, 2, 3, 4, 5, 6, 7, 8?
No.
Shit, no. What's the highest I want to go? 25. That breaks up easy if you use
5.
fives. I like it. So 5, 10, 15, 20, 20. Take it. RF, real freak. Now, get that copy, and then put your pencil down for a minute. Don't write what I'm about to write. You don't actually have to put it down. Just don't write this. I'm going to make a mistake. Okay, there's a mistake I made.
They're
Because if
not-
I go to make little little rectangles on this, what's it going to look like? Isn't it going to look like there's empty spots?
Yeah.
Are there supposed to be any empty spots?
No.
No, there's not supposed to be any empty spots, damn it. You've led us down blind path, Jeff. What the hell? So, the shit. So here's the idea. All right, you're gonna love this. No idea how you guys think about me, I don't care. I have a limit to me, right? Like Jeff stops right here, and then right there's not Jeff. You with me? That is so weird, I don't care. There's a limit to Jeff. I also have a boundary that if you step inside of that boundary, you better be a good friend. You with me? Okay. Okay, I think you're honest. So what this shit does have to do with this? Nothing. No, here it is. These are the limits. The boundaries are half up and half down. Watch what happens if I do that. So this would be actually 10.5. By the way, don't write these here. I'm just doing this to show you. And this would go to 20.5. Is everybody with me?
Yeah.
A little down, a little up. Where does this go?
20 or 20.5.
Don't they line up now?
Yeah.
There's not going to be a gap anymore? Do you guys like having to do that? I wouldn't want to if I didn't have to. So I'm going to show you the other way in a minute. People normally stick with this one because it's what's in the book. But I'm going to show you a different way to do it. So here's what this would look like. 10.5 up to 20.5. And then I can just count by what's. Because of course, what's my width supposed to be? 10. Notice how you can see 10 now? Now you can see it. Stupid 10. Hiding. Jeff, you can add? No. Don't let them know that. Okay. I don't know how to add. We'll be all right. And now now it's the easy part. Right? How tall is the first bar going to be? How tall is this bar going to be?
3. No. 18.8.
Yes, 18.8. I wanted exactly 18.8. And then of course we've got a couple of, is everybody, this is the easy part. I've got a couple of 25, so I can just go, one big ass one, there we go, yeah. And then I got another 18. Wow, why'd you do that? Jeff, sorry. And then I got a 12 and a half. Let's see if you guys know this. If you're being really lenient, is this loosely normal? Does anyone know what a normal curve is? Anybody ever heard of a normal curve or a bell curve? The bell curve you've heard of, I know, maybe, right? The bell curve? So does this look roughly, maybe this sucks, this side sucks. A really normal curve should be like this. You see how it looks like a bell?
Yeah.
Okay. But you can say certain things are loosely normal. This one I'd say is no, not quite. It's kind of sucky. It does go highest in the middle, but it doesn't really go down. It's not really symmetrical on both sides. Okay, maybe that's going to come later. And I'm not done yet. I forgot what this was. Were these just stupid agents, or what? I didn't even say what this was, did I?
No, we did ages of people at a bus stop.
All right, so these are made up numbers. So what I'm trying to say here is label your axes. Now, last thing before I give you a worksheet to work on so I can shut up. Here is what this would look like. Here's another way to set up your classes. Let's see if anybody likes this. I hate doing this shit. I much prefer this. But again, I don't care. Whichever way you pick, I don't care. You can do this. People don't like that because they had a bad experience in algebra, and that reminds them of algebra. So they're like, I'll be okay with the 0.5 thing, Jack. But it's up to you. You can choose it. Why can I put a 21 there? Because where would 21 go? And the second one, because that's where it's allowed to equal 21. See that? But it can't be 31. 31 would go there. So then then this would be 11, 21, 31, 41, 51, 61. Yay! No 0.5s. The trade-off is inequalities and an X that you have to write. But you can choose either way you want to. Yes?
You said you were gonna give an example of why you wouldn't wanna use, since the range was 48, you can divide it into 6, why you wouldn't want.
Oh yeah, thank you. Real quick, if I would have used 6 classes, the width would have been 8. Now watch this. This is neat. 11, 19. Is everybody with me? I'm just going to add 8 down, right? So I'm going to kind of redo this. I just said I can't add. There we go, Jeff. Is that right? 8, 8, 8, 8, 8, 8. Okay. 8, 8, 8. Stop it. Oh, let me see. 1, 2, 3, 4, 5, 6. Aren't there 6 classes right now?
Yeah.
Did I capture the last data point? But didn't I want 6 classes? Damn it. I want 6 classes. Damn it. So what I can do, you guys look at me like, is he all right? You take all his meds. So what I can do in this case is, this is the one time I'm allowed to do this. Just kind of suck that last data point in. Because it's sitting right next, you might as well bring him in. That's a little weird, right? And that's why it's almost better if it doesn't go in even.
So you can only change the last one by only 1, or can you do it by like 2?
By only 1.
Okay.
Yes.
Is there a way to like tell like exactly how many classes to use, or?
Oh, all right. It's interesting you say that. Let me tell you this. There is a formula for the right number of classes to use based on the sample size that uses logarithms. You want me to make you do that?
No.
Do you know what logarithms are?
Logarithms, no.
Remember logarithms?
Yes.
You want to?
I don't even know.
All right. But all right, I'll stop being a jerk. There is a formula for knowing how a good number of classes to use. It does use logarithms. Yeah. So there's a way to kind of formally do it, but it's so much stuff that we have a flexibility on choosing. Who really cares if it's exactly right? So smaller the set of data, the more you should use 5. So if you use 5 or 6 for our data sets in here, you'll be fine the whole time. I'm not going to give you 800 data points. You're welcome. Right? Okay. So let me give you this. The back of this paper is where you have to construct your own histogram. So if you want to start in the back, feel free. And the front's got some stem and leaf stuff and some questions about a histogram that was already created. Right? So it's up to you how you want to do it. Yes?
So how do we convert that to a graph and calculate?
Oh, I don't know.
Like the data set that we have right there, how do we make that into a graph and calculate?
You can do it. I'm not going to tell you.
because I want you to do it by hand.